So if our positive E zeros, whether it's E cell or the reduction potentials out of the table or whatnot, the positive E zeros are for spontaneous processes, and we've also defined spontaneous processes as things that have a negative delta G associated with them. So there has to be some relationship between E0 and delta G. So E0 versus delta G0. They are related to each other because they both let us decide whether something's spontaneous or not. So they have to have some sort of relationship between them. Now, strictly speaking, the work that can be done by a reaction is minus delta G. So spontaneous reactions have a negative delta G. The work that can be done is the positive form of that. Work can't be negative. Okay, so if we can do work with something, we flip the sign on delta G, that's how much work can be done. So minus delta G is the work that can be done. By a reaction. So that's from the delta G side. And NF, capital F, E cell, that's the maximum work of an electrochemical system. Now we got to be careful how we look at this here. N is the number of electrons in an overall reaction. So it's not just the 1 electron or 2 electron stuff that we look up in the book when we look up our E zeros. It's after we balance the reaction, how many total electrons were transferred in the process after we balance oxidation reduction numbers of electrons. It might be 1, it might be 2, it might be 3. Sometimes it's a lot more than that. Sometimes it's a 6 electron process. We balanced a reaction a little bit ago where we had 6 electrons in our balanced setup. That's the N that goes here, the number of electrons in the balanced half reaction. F is Faraday's constant. That's the 96,500 coulombs per mole of electrons. At standard state, it would be E0 for the cell. If it's not at standard state, we just drop the E and we can still calculate it. Okay, we'll get here in a video or two to what happens at non-standard conditions. So if both of these represent work that can be done by the system, there has to be a relationship between the two. And there is. Move that one up out of the way a little bit here. So delta G0 for a reaction that we would calculate the same way we did all of our others, either from tabulated delta G values or from H and S values or whatever. So delta G0 for a reaction equals minus NF E0 for the cell. The negative sign here was not here before, but it was up here. This is just one version of this. You can rearrange it however you want. Okay? If we do this at non-standard conditions, different temperature, different set of concentration conditions, or whatever, delta G is minus NF E cell. We're just about ready to start talking about it non-standard conditions here, and we'll get to that. But what we're going to do is look at two examples. I'm going to give you a couple of E0s for cells. You know, you might come across problems maybe in a homework set where you have to balance an equation, come up with E0, calculate delta G, calculate K for the process, because they're all related. We have relationships between delta G and K, therefore we also have relationships between E and K. And we'll get to those eventually also. But for now, we're going to do two examples. where we have to calculate delta G for a process given an E0. Okay? So we're going to calculate delta G0 for a 2-electron process with an E cell value of plus 0.125 volts. So we're essentially converting 0.125 volts on a 2-electron process into delta G. Now before we get started on this, E0 for the cell is positive, right? That means this is a spontaneous reaction. We'd better get a spontaneous delta G out of that. We better get a negative answer, right? So here we go. We're going to plug this guy in. Delta G0 is minus NF E0 for our cell. So we plug in our numbers. Minus 2 moles of electrons. F is 96,500 coulomb per 1 mole. So that right now is coulomb to charge, right? E0 was plus 0.125 volts. Now before we calculate this out, Dr. Schrader, none of these units are going to cancel. What the hell's going on? Well, the moles cancel straight up, but coulomb, we had coulombs per mole, and a volt was 1 joule per coulomb. So the coulombs do cancel out. We're left with joules. Beware that it is joules though, right? Because usually we're asked for kilojoules per mole on delta G, because that's the unit that makes the most sense. So it does not look like the units all cancel from what you're given in the problem, but they do because 1 volt is 1 joule per coulomb. So the coulombs cancel, all the units cancel except joules. Okay, so delta G equals, plug in our stuff, minus 2 times 96500 times 0.125 equals minus 24125 joules. And this will be per mole of balanced reaction, right? Just like we did back in the day when we were doing these delta G problems. So it's still joules now per mole of balanced reaction, because this represents the balanced reaction. So this would be minus 24.125 kilojoules per mole, which would be most like what we're asked for. What's the delta G in kilojoules per mole units? So like I said at the start, if E0 is positive, we'd better get a spontaneous and negative delta G out of it, right? And we did. So these are all work just like this. Once you know what E0 for the cell is, either you're given it or you have to calculate it based on an equation that you were given, a chemical equation. You do need to know how many electrons are in the process. Don't forget that this doesn't mean that the electrons in one half reaction or the other. It means after the half reactions are balanced, how many electrons did you cancel at the end? When you cancel the electrons, that's the number that goes there for N. Okay? Always look at your answer, make sure it makes sense with your E0. Positive E0 means a negative delta G, because those both mean spontaneous. All right, we're going to work one more example, just kind of like this, and kind of see what happens when E0 is negative. All right, be right back.